Hello students, now let us try to understand the concept of ideal gas. Okay, student, the ideal gas is what? A gas which obey the gas law equations under the all condition of temperature and pressure is called the ideal gas. That is also known as perfect gas. Okay, so first point is what, student? If any gas is obeying the gas equation at all condition of temperature and pressure, that would be the ideal gas, or you can say in another word, that is the perfect gas. What is the second point? Number of gas is 100% ideal in nature. Every gas deviate more or less from the ideal nature, so all gases are called the real gas. So this point is very important. They are saying that is all the no gas is 100% ideal in nature. No gas is 100% ideal in nature. Every gas deviate more or less from the ideal nature, so all gases are called real gas. Next one, the real gases deviate least from the ideal nature at high temperature and low pressure. See, if the real gases deviate least from the ideal nature, that is high temperature should be, if high temperature is there, so real gas deviate least, and low pressure, at low pressure it will deviate least. Now the real gases deviate more from the ideal nature. Okay, the real gases deviate more from the ideal nature at low temperature and high pressure. Okay, at low temperature and high, the real gases deviate more from ideal nature. The real gases deviate more from the ideal nature at low temperature and high pressure. Okay, now next point you see, student, lighter gas have more ideal nature than the heavier gas. Whatever the lighter gases are there, they are having the more ideal nature compared to the heavy gases. Next point, student, at a constant temperature and pressure, volume curve of the ideal gas and real gas are shown below. Okay, so ideal gas is like that, more steeper compared to real gas. Okay, at high pressure the measured volume determined experimentally deviate more from the calculated volume, usually using Boyle's law for any gases. The real gas constant for Avogadro number of the gas molecule is called universal gas constant or molar gas constant. The gas constant for one molecule of the gas is called Boltzmann constant. K is equal to R by N. The gas constant, the gas constant, the gas constant for 1 mole of ideal gas is called Boltzmann constant. The value of the Boltzmann constant are K is equal to 1.38 into 10 power minus 16 or Kelvin inverse molecule inverse. K is equal to 1.38 into 10 power minus 23 Kelvin Joule Kelvin inverse molecule is. The relation between the universal gas constant and Boltzmann constant is K is equal to R by Na. Na is the Avogadro number. So we have to understand the Boltzmann constant in the next question, student. Thank you so much for watching, students.